On this channel, we've really begun to dive into the ever-changing game of data-driven player development. Specifically, we've done a ton of talk about pitch design. What things can be done in order to sharpen our athletes' current arsenal? We talked about the fastball in a previous video, but let's take this a step forward. In today's video, we are again going to dive into the data-driven player development tools and how they can help shape a player's curveball. Before we jump into it, welcome back to another video, guys. If you're new here and you're a coach, player, or trainer interested in learning more about the practical applications of data-driven baseball, you've come to the right place. Join the movement now by clicking the subscribe button down below for more weekly baseball animations. So before we begin to dive into what changes need to be made, we need to first outline what a typical curveball looks like. Like our video on the fastball, we will base our numbers off of MLB averages, but know that most of these metrics can be scaled down to help you develop pitchers at any level. To begin with, the typical MLB curveball comes in at 77 miles per hour. You may see a larger range of successful curveball velos starting at around 65 miles per hour and going up to almost 85 miles per hour, but on average, this pitch will clock in around 11 to 18 miles per hour slower than each player's fastball. The average spin rate of this pitch is a couple hundred RPMs higher than our typical fastball at 2,500 RPMs. But as we discussed in our Bauer units video, spin rate alone does not tell us the full story of high or low spin. So on that scale, anywhere from about 28 to 30 Bauer units are going to be clocking in with average spin for that certain velocity. Now, the entire MLB usage percentage of this pitch has stayed pretty consistent over the last 10 years at about 10%, coming in at just about 11% in 2019. When we talk about the advanced analytics of creating a curveball, we're going to focus on three main things: the spin axis of that pitch, the spin efficiency of that pitch, and the horizontal and vertical break of the pitch. We'll dive into those aspects here next, when we talk about what pitch profiles make a good curveball. Here are spin direction or tilt and our horizontal and vertical break charts we've seen so often here on this channel. These are the best way to visualize the way each of these pitches move. It is important to note that before we jump into this, that we will be focusing on a right-handed pitcher in this video, and all the same is true if you just flip these diagrams for left-handed pitchers. The true 12-6 curveball that we all know and love is typically a pitch that comes in with around 6 or 7 o'clock tilt, and much more negative vertical movement than any horizontal movement, meaning that the pitch is going to move more up and down than left and right. You may have some pitchers, though, that throw more of a slurve, which will fall into 7 or 8 o'clock tilt range. These pitches will have similar numbers when you compare their negative vertical break and horizontal break values, putting them in the middle of our bottom left quadrant on the horizontal and vertical break chart. And lastly, breaking balls thrown between 8 and 10 o'clock tilt are going to be classified more as sliders. We will jump into that in a future video. Just know that with any pitch here, but especially the breaking ball, that your biggest indicator of a pitch's movement is going to be your pitcher's hand position at release. If you'd like to hear more about that, and if you'd like to see a video on sliders sometime down the road, please let me know in the comment section down below. Now, one of the biggest things I'd like to stress when talking about designing a good curveball is that you want the movement profile to be separate from a pitcher's slider if they throw both those pitches. Too often, especially with younger athletes, do I see these two pitches' boundaries beginning to overlap. I've said this before on the channel, but if you have two pitches with the same movement profile and you throw one harder than the other, that pitch is going to be better. So when dealing with a curveball, make sure to have ample separation from the rest of that guy's pitches. While we're on that note, the best curveballs that I have seen are going to be more true curveballs. As you get more and more slurvy, even if you don't throw a slider, that pitch tends to be hit around more often than a true 12-6 breaker, with more negative vertical break than its horizontal break, or if it falls between that 6 o'clock and 7 o'clock tilt. The next biggest issue that I see is going to be curveballs thrown with low spin efficiencies, or below 70% spin efficiencies. We've talked about gyro spin on this channel before, but that is the amount of spin that actually aids in movement. If you'd like more info on that, check out the link to that video down in the description. But for the sake of this video, you can visualize pitches with lower spin efficiencies moving closer to that 0-0 mark on our chart, and pitches with higher spin efficiencies moving away from that 0-0 mark. In the case of the curveball, you want to be using as much spin as you can to maximize movement. so chasing a higher spin efficiency is a great and easy first step when working with athletes. Like anything we talk about on this channel, working on the curveball is just another piece of each athlete's puzzle. We are always attempting to prioritize what work needs to be done in order to take this athlete to the next level. Lastly, this is a pitch that a lot of people struggle to tunnel with. We have a whole video on tunneling, so click the link down below if you'd like to see more on that, but you want your pitches coming out of the same slot and looking like all of your other pitches until it finally breaks off. That's what's going to generate the most swing and misses. That being said, your first priority should always be to create the spin that you want on that pitch before you begin to work on tunneling. To recap what we said earlier, the higher the spin rate, the higher the spin efficiency, the greater the movement is going to be on that pitch. Then you would like to start working on getting the correct spin direction, and tilt is going to be your next big step here. As you begin to hop in and work on your release point, even if you have the nastiest pitch in the world, but that pitch pops out high and out of the hand, the hitter is going to recognize it straight away. You aren't going to have much success with this pitch. That is another common issue I see when working with athletes on their curveballs. You'd like to eliminate as much pop out of the hand as you can. Working on breaking balls specifically is a lot like a maze. You start by taking a look at what they currently have, and you work and work and work, give cue after cue until you find one that sticks that will help that athlete succeed. In general, most pitchers with a straighter fastball are going to be more comfortable throwing a true curveball, which is something that we already knew and observed just with our eyes, but it's cool to have this data back that point up. 3/4 slot guys often throw more of a slurve, and while that's not bad, I've seen 3/4 guys truly develop nasty curveballs that do act more like a true 12-6. On the contrary, lower slot guys tend to have more success throwing sliders. When we begin to talk about pitchability, most people with above average curveballs should work their fastball up in the zone and their curveball down in the zone in order to tunnel these pitches the best. Over the last few seasons, due to the technological advances in pitch design, the average MLB spin rate on the curveball has risen over 200 RPMs, from 2300 to 2500, which in turn increased the average amount of negative vertical break to increase 2 inches from 5 inches to 7 inches on the average curveball. This is a quantifiable way to see how the use of this technology is aiding player development at the highest level in the game. By decreasing gyro spin and increasing useful spin, guys are now throwing better breaking balls than ever. And that's what I've got for you today. My take on what aspects of the game you need to understand in order to truly master the pitch design process for each guy's hammer. Specifically, utilizing today's technology, this is the second pitch we've really dug deep into the analytics of. So if you're interested in seeing more on how you can improve pitchers' arsenals, let me know in the comment section down below. If you enjoyed this video, please leave a comment down below with any questions or suggestions for a future video. Leave a like if you enjoyed or you just want to support the channel, and subscribe for more weekly baseball animations posted every Wednesday.